In this episode of the Code Review series, Cherno viciously attacks an 11-year-old for trying to program. Hey, what's up guys, my name is Cherno, welcome back to my Code Review series, aka my roast review series where you guys send me your code and I roast it / sometimes give helpful advice and feedback. Today, we are roasting Real Engine. You guys have heard of Unreal Engine. Well, what if I said that there was something that possibly could be, I don't know if better is the right word, more real though? We have Real Engine by Anthony. Hey Cherno, I hope you're doing well, my name's Anthony. I'm 11 years old. 11 years old. Do we believe that? Do we not? Let me know in the comments below. I guess time will tell. And I'm currently working on my own game engine. Yes, just like any 11-year-old really would be doing these days. I mean, I didn't start programming till I was like 16, so this guy's got it on me. Because who needs sleep, right? I've been learning as I go, and let's just say that it's been a wild ride of why didn't I think of that sooner? And oh no, what did I do wrong? Yes, I too was frustrated as an 11-year-old trying to write game engines. Anyway, I've hit a bit of a wall and I figured I'd reach out to someone who actually knows what they're doing. Why, thank you. I'm not expecting a gentle pat on the back here. In fact, I'm fully prepared for the what were you thinking roast. Seriously, bring it on. Here's the issue. Oh, there's an issue. The IMGUI file doesn't work. And it shows me something like colon is confound. I'm guessing not found? Confound, what? Or something along those lines. Colon is confound. Confound these columns. I've tried mention any things you've tried if applicable. What? Is this like a template? Has someone released a template on how to submit code review videos to me so that I actually review them? What if AI compiles like a list of commonly found phrases or keywords that are in these emails that lead to me actually accepting the project and doing a code review on it and it making it to a video? I wonder if like that's something that's like, hey ChatGPT, help me write something so that Cherno will actually make a video on my project. That would be interesting, but yeah, that's bizarre. That's so weird. Maybe he just like was writing it and then he's like, I'll come back to that later and then forgot. I'd really appreciate any feedback or thoughts you have, whether it's a complete overhaul suggestion or just a stop doing that moment. You know, just the usual. Looking forward to your insights and the potential roast. Okay, and then we've got a website. PS, if you think I should scrap this whole thing and just start a career in something safer, like accounting, feel free to be blunt. I don't know, I think like software engineering is a fairly safe career. I can take it. Also, sorry about my English, even though I speak it more than Polish, it's still a work in progress. What an email. Okay, so we've got a website here. Let's have a look at this. I have already cloned the project, by the way, that's why this is purple. Want pre-built binaries? We're gonna leave that blue. Okay, and then on the GitHub page, this is what we have. Let's talk about this for a second, because if this guy is in fact 11 years old, then this is great. So first of all, he's got a README. He's got a license. He's got, even though installation's misspelled, doesn't matter. He's got instructions on like how to build this, including even how to clone it, open the solution file in Visual Studio, which not a great thing from a point of view of the build system, having a solution file like this, but it doesn't matter. This is more than most submissions provide me with. And this guy is 11. So this is like, if you don't have this going on, a GitHub repository with like some instructions and a README, you really have to reevaluate what you're doing. And then the other thing that stands out to me is pre-make. Like, okay, so yes, a Visual Studio solution file seems to have been included, and in fact, here it is. Over here, there is in fact a pre-make file, which obviously looks very basic, and I can actually tell from here that it looks like there's just a Real Engine solution with a single project. So we can talk about architecture and how you generally don't have like both your application and your actual core engine in the same project. But again, the roasting is probably going to be kept to a minimum here, and I'm more or less going to be trying to give some advice considering this guy's 11 years old, or at least he says he is. The other thing that I want to point out real quick is that there seems to be an x64/release folder here, which contains the exe, a PDB, and an IMGUI INI file, which is just like the layout of your Windows in IMGUI. This should not exist. The INI file is kind of important. I would probably just have that in the project directory or something, considering that's usually the working directory in Visual Studio anyway. But checking in PDBs, EXEs, not something that you do. If you want to release, then make a release on GitHub. I've mentioned this before, just create a new release with a tag, and then there you can attach like executable files. Probably not PDBs though, like as in you can attach any files you want, but you wouldn't attach PDBs because they're usually for debugging. PDB is a program database file, which contains like debugging information. All right, then it looks like we have Real Engine with again an x64 release with a whole bunch of intermediate. So these are all files that don't need to be here. They were added via upload, meaning that, to be honest, I have never used this feature, but I think you can, like on your own repository, you can just like upload files. to GitHub. Like you don't have to go through Git and actually push it and commit it like to a local repository, then push it to a server, to a remote repository like this. I think you can actually upload files using GitHub now, which would have been helpful to me like 20 years ago or whatever, maybe like 15 years ago. Because I remember like when I was first learning programming back in like 2011 or whatever, I was like, GitHub seems to be the place where people publish their code, but how do I get my code on GitHub? Why isn't there an upload button? Because I knew nothing about version control or Git back then. I just thought that it was like Facebook for for code. How far we've come. Okay, anyway, let's get this project checked out. Oh, look, it's already here. Realengine.solution. I will open the solution file since it is present, but otherwise I'm guessing in this vendor folder, there's like this pre-make file, which you can, are there scripts to run that or no? Okay, so that's another suggestion. Make a little batch file that you can just double click to run that, because otherwise, yeah, in fact, otherwise, I mean, you don't even have that here. I wonder if that works. Do I risk it though? Because if it doesn't work, then obviously that's going to be really annoying. But at the moment, without a batch script, you'd have to go to like vendor bin pre-make 5, and then VS 2022, I guess, like that. And then it would regenerate this, which yes, that has in fact destroyed everything. Everything used to be here. Now it is not. So now I'm going to have to go back here and then like git check out everything to get the original solution file back. Nice. Now, it's always a good idea to get as many eyes as possible on the code that you write. That's one of the reasons why I do these code reviews in the first place. And that's also the reason why I love the idea of using AI code reviewers such as CodeRabbit AI, the sponsor of this video, which by the way is completely free for open source projects. Getting AI to take a look at your code and pick up mistakes that are really easy for humans to miss is just such an advantage. And at the very least, you're just getting another set of eyes to take a look at your code. And there's also no need to spend time waiting for those human set of eyes to arrive. CodeRabbit can seamlessly integrate with GitHub or GitLab and scan your pull requests in real time, highlighting potential bugs, security issues, and even improving code readability and structure. It's a great way to get instant feedback on your work directly where you work. I also think it's really great if you're learning programming. I know when I was learning programming, it was difficult to get someone experienced to actually look at my code and give me feedback. CodeRabbit acts like an interactive mentor. You can chat with it, and it can offer detailed explanations for suggested changes and help you learn best practices. You can try CodeRabbit for free for 14 days. Just click the link in the description below and see what it has to say about your code. Thank you to CodeRabbit for sponsoring this video. Okay, so here's the project. It's here now. We've got it here. Beautiful. What was that problem that he was having again? The imgui.h file doesn't really work, and it shows something like, oh yes, is confound. We'll take a look at that. Let's just try building everything first, I'm guessing. All right, so we get an error straight away. Let me just do a clean build, considering nothing here was clean. Had like intermediates and everything. Okay, so we're still getting this error with the precompiled header. I mean, look, he's using precompiled headers at 11. I think it took me years of C++ probably before I even knew what a precompiled header was. So doing well. It's not working, however, so that's not doing well. So what's the actual file? So glad.c. Glad.c is using realpch.h, which is obviously using C++ things. Yeah, I mean, the error message kind of sums it up. It says that precompiled header file is from a different version of the compiler, or the precompiled header is C++, and you're using it from C or vice versa, which we are in fact using it from C because glad.c is C. So I don't know how, I mean, glad, first of all, is an external dependency. So you wouldn't, I mean, you can include it in this actual project. I think one thing that Anthony could really benefit from here is just being able to work with multiple projects, right? So typically a project results in some kind of build target. It's either a library or an executable. And then we have two different types of libraries. We have a static library and we have a dynamic library. Dynamic libraries are a little bit, I would say, outside of the scope of what most people are doing. And in fact, even me, it's not that often that I actually make my own dynamic libraries. Like that's just not something that happens too often. I am definitely on team static library, but also for my needs, it just seems to be better and way easier and has so many benefits that make dynamic libraries just completely not useful at all. So we can ignore the dynamic libraries and just think about static libraries and executables. Of course, you can have many other targets, like any kind of project target or whatever. It could just be like some commands that get like run inside like a shell to, you know, build shaders, for example. But we don't need to talk about all those kind of utility projects and other complexities. We can just think of it as, okay, there's an executable and there are static libraries. Static libraries allow you to modularize the bits that make up your software, and something like Glad, which is an external dependency, instead of including that inside this project and basically almost like giving it all of the attributes of this project. You can instead make a new project for it that builds into a static library, so the end result is basically the same when it gets put into your eventual executable, which you're building towards, but it lets you more easily govern the rules that surround that particular build for that thing. Of course, it also like segregates that into a separate module so that it's not affected by things that might affect, you know, the project you're currently working on, which leads to like not rebuilding as often and some other benefits as well. But the reason why that would have been beneficial for you here is because I reckon the reason why this is even here in the first place is because it's mandatory for you to suddenly include precompiled headers in every single CPP file that is inside this project. Because if you mark the project as using precompiled headers, which I don't think, by the way, the pre-make was actually doing, but again, I suspect that what's happened here, because it doesn't mention PCH as like here at all, I suspect that pre-make was probably his attempt to just maybe move away from the Visual Studio solution which he started with and actually make this a bit better, which is definitely a good plan, right? But it's obviously not quite there yet. So that being said, in precompiled headers, you can see we're using precompiled headers. It's just marked as just being used. You can see across all configurations inside this Real Engine project. And then the precompiled header file is this real pch.h. So when you actually mark a project like this, it means that every single CPP file has to use it. If glad.c was inside its own little static library called glad, it would have different rules and this just wouldn't be a problem, right? So that's one reason to do that. Now, how did this build at all for him? I don't know, because this is a C++ code being included in a .c. It's possible that maybe this was marked to compile as C++ somehow. I'm not exactly sure. The way that I'm going to fix this for now though, because if I try to remove this, I suspect it's going to say that, yeah, unexpected ended file while looking for precompiled header. Did you forget to add include real pch.h to your source? So that's probably what he saw, and then he added it, but then I don't know, it didn't work. Literally the only way I think this may have worked is if he did in fact compile this as C++, not C, somehow. But again, because I have the exact Visual Studio solution and project files that are in the repository that he presumably built with, I don't understand how that could have happened. What I'm going to do to fix this is, yeah, I am going to remove this as I did earlier. And then if I go to the property pages for this specific file, so not the project, but the actual file itself, I'm going to manually mark just this file as not using precompiled headers. And then if I do that, Control F7, you can see I should be able to build it as normal. So you can obviously exclude certain files from using precompiled headers kind of one by one. Again, I would still recommend moving glad into its own like module, into its own static library where you're just not using precompiled headers, and then possibly have other build settings as well. But yes, it's possible to give specific files their own build settings, and it's also possible to do that inside pre-make as well. Okay, so now let's Control-Shift-B and try and build this. Okay, it was not. I thought that was the only error. This is what happens when I don't try and build projects that get sent to me before hitting record. Okay, so unexpected. So we got like a bunch of files that just don't have. Okay, so this is another reason, right? So IMGUI should not probably be here. So you can see all dependencies. I mean, GLFW is just being used as libraries here. So we're not actually compiling GLFW from the source code, which is good, I guess. But IMGUI is in fact being compiled from the source code. And you can see every single file is going to be expecting that precompiled header. How is this submitted? Like, okay, he's 11, right? He's 11. Okay. So gotta be nice. Okay, so I mean, I guess what I'm gonna have to do is just mark all of these as not using precompiled headers. So what you should do is for every like third-party situation that you use, you need to make sure that you like just make that a static library. That's your homework. Make it a static library, and then you know, I mean, you can do that through Visual Studio. Add a new project. It's been a while since I tried doing this through Visual Studio and not through a build system like CMake or Premake, but static library, right? Make static libraries, and then you just go like right click, add reference, and then you can pick like projects, and you can see if you had another project here, you just tick it, and then that way it gets kind of built and included. You still have to like set the include paths, but it will get linked, and it'll also be a build dependency of that project. Meaning if you build this project, it will also automatically build all of the dependencies. Do that with glad, do that with IMGUI, and then GLFW, I don't really know why. I mean, I'm in show all files mode, which is why it's here. But anyway, just do it with those two, please. Okay, let's try and build this again. What's going on here? So we're getting that for all of the actual files though. None of them actually include that precompiled header. So was this just like an experiment? Okay, Okay, I think I've been tricked here. So I think maybe the project should just not use precompiled headers. I probably should have done this like as a first step, just because that would have just made everything work immediately with no possibility for other files not including it. But I thought that maybe it was just missing from a couple files. I don't know. All right, then we got layers is not a, I'm just fixing code here. Okay. Okay, so as I work my way through this and I'm trying to fix this, I track down layers as being the file that doesn't compile, and the error is pretty much nonsensical. Like, it's telling me that layers is not a class or namespace name, whereas the code you can see, it's just these two files. Extremely simple, and I'm just compiling this CPP file. The reason all of this is happening is because this precompiled header is being included in many, many, many headers. And when that happens, it's very, very easy, obviously, to wind up with recursive includes. And to be honest, in my many, many years of C++ experience, if you're getting seemingly nonsensical errors, recursive includes is like the #1 most common reason. It is technically okay to include precompiled headers in other headers. I've seen it done before at EA. We used to do that all the time as well. I'm generally not the biggest fan of that though, especially if you take a look at the contents, right? So the idea, I think, of why people even do that to begin with is because it just makes things easy in the sense that you don't have to worry about what's included and what's not. Because if we look at the precompiled header, it literally includes everything. Like lots of stuff from the standard library, lots of stuff from dependencies, and then our code. Everything is basically included. We got like Windows.h this version. Oh, nice. This is nice that it's not like, what is real Windows currently support GPUs. Just supports an NVIDIA 3050 apparently. That's so funny. But regardless, also seems to have some Mac support, which is pretty cool. Anyway, I'm getting ahead of myself. The point is, in a way, I guess it exists to make things easier, but things obviously go wrong because what's going on here is that, like, since layers and I'm GUI layer, as an example, I've picked these two. If these both get included in both of these, that means that layers includes layers .h. I mean, that's already a recursive include, isn't it? But I was going to say that layers includes I'm GUI layer, and I'm GUI layer includes layers. So there's that recursive include. It's 100% okay, obviously. In fact, it's required if you're using precompiled headers to have your precompiled header in your CPP file, but just don't do it in header files. Just try not to do it. It gets too messy in the end of things. Unless it's from a different module, I guess then it would be okay. So for example, if you have a precompiled header for your game engine and then the game project, which is a separate module, it's an exe maybe, and then the actual engine is like a core library, it's a static library. In that case, I guess it would be okay to include the game engine's PCH inside a game header file. That's obviously not what's going on here. Everything is in a single module. And the reason why that would be okay, by the way, is because you couldn't possibly shove stuff from the game into the game engine's precompiled header. So therefore you're not going to get recursive includes in that sense. But I would just be like, no, like don't do that, because headers, like, just generally try and keep them as lean as possible. Only the stuff that's required should be in your headers, because that's going to get included in other headers, in other source files, all that stuff. But in the CPP files, you can definitely be a little bit more free, a lot more free, to be honest. Now, this is somewhat of a special case, because if you have a look at what's actually here, there is zero. Like, this is such a bare bones engine. I'm now realizing that there is like, this is a class called layer and there's nothing here. Like, this is the CPP file. This is the header file. There's nothing here. So this doesn't need a single include, not to mention every single include in existence, right? So that shouldn't be here. This shouldn't be here. It does need layers, obviously, like, as in it derives from layer, which, by the way, this should be public. If you don't have public here, then this reverts to private inheritance, which means that everything that like was public suddenly becomes private, and there's some other semantics as well, but generally almost never like a reason to do it, and certainly not in your case. So just make sure that that's public. And then here we would just include, like, where is this layer thing? So renderer layers, just like that. Let's try and build everything again. We might still have other things that will cause some issues. So many warnings as well. Okay, there we go. Build succeeded, finally. Let's run this. I'm surprised it actually does something. I was expecting all the code to be empty. Okay, so what do we have here? So failed to open. Okay, so we're not opening the shaders that we need. And I think we probably don't have a valid shader, which is why it's crashing when OpenGL is actually trying to render using those shaders. Let's have a look at why the shaders aren't loading. Okay, so the shader programs are in renderer shaders. So if we have a look at Real Engine, we have source renderer, and then the shaders are just kind of over here along with the source code. I also wouldn't do that as well. Shaders are like external data, external assets. You should treat them as such, not as like source code within, like amongst your C++ files. So I mean, I'm not really sure why this isn't working. I mean, I am. It's because the working directory is nowhere near this. The working directory, I think, is just going to be this. So really it should be in source renderer. So I don't know how this was working. The only way that you can get this working is if you actually go into here and then debugging and then set the working directory manually to like be that source directory. Or of course you could like build the executable, create a shortcut, and then set the working directory in that shortcut. Anyway, let's try run this. Okay, still can't open that stuff. It is suspicious to me though that it's saying fail to, let's just search for this. So that's happening in shaders and then the file path. Let's actually put a breakpoint here and see where that's coming in from. Okay, yeah, so it's losing part of the path for some reason because it should have that entire path. That doesn't make any sense, does it? Oh, my gosh. Wonderful. Let's take in some parameters and then completely ignore them and just hard code our own paths. Awesome. I just love stuff like that. Okay, let's replace this with this. Sometimes I question the kind of content I make. Okay, well, it's working, but it's not working. If you think I should scrap this whole thing and just start a career in something safer like accounting, feel free to be blunt. Not yet. I have hope. It's funny how the issue that was pointed out was imgui.h doesn't really work. Yeah, like it's imgui's fault. Anyway, let's pivot a little bit. Instead of like this being a roast review or a code review, let's make this Cherno helps an 11-year-old programmer because he's so nice. And I'll leave it up to you to decide who's nice, me or the 11-year-old. Okay, so this is why I don't like OpenGL. I mean, we probably don't have OpenGL errors hooked in. Let's maybe do this. You know what, guys? Let's be a little bit charitable here. One thing I could do is I could literally, with all these changes, submit a pull request and be like, hey, I made this like work and I fixed your errors for you. Wouldn't that be nice? Wouldn't that be nice as like a little Cherno helps the community series? Like, is that what this has come to? Because like, it would be definitely very nice if we had like an OpenGL like debug callback set up, which I have no idea how to do. I mean, I did one day, but it's been a while. The other issue is that like, that doesn't work though. That doesn't, like the OpenGL debug message callback does not work in 3.3. So I found it over here. You can see it's available in like 4.3 and onwards. Now there's no reason for us to be using 3.3 on my current hardware. So I could definitely make it be 4.3. And then you can see we can have GL debug message callback. The problem is though, to actually have that function available to us over here, we need to actually tell GLAD that we want to load a different version of OpenGL. And since GLAD is a generated header file, like as in you go to this website over here, and then you actually like say that you want core. So for example, 4.3, I mean, I would just go like 4.6. But anyway, you say that you want that, and then you hit generate, and then it actually makes the header file and like the CPP file that loads all those specific functions and extensions, blah, 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 for you. So point being, like we need to actually do that. You know, let's quickly do that because I think this will be useful, right? For everyone, maybe. I don't know. Okay, so 4.6, we'll go with core. Okay, let's go a little bit down. We'll go 4.3 core. In fact, let's just keep it compatibility because I don't know what other OpenGL code lies here. Some of it may have been deprecated. Let's hit generate. This is going to just give us like a zip file of stuff. And then if we take a look inside the zip file, we have include and source, right? So this glad.c file, I'm going to replace our existing one that we had here in this project with this one. And then inside include, there's glad and khr. I'll just copy both of these directories. And then if we navigate to this directory, I'm going to paste them, replace them all here. Okay, and now we've, just like that, we now have OpenGL 4.3. And again, it's not like we've obtained OpenGL 4.3. That specification like is basically implemented by our GPU drivers. So it's the actual NVIDIA driver that I have inside my GPU. Well, it's not really inside the GPU, but you know what I mean. That's what contains those actual OpenGL functions, which map to code that NVIDIA has written, but this code just simply like loads them. So I've just updated the loading code to now include functions that are from OpenGL 4.3, which now means that I have access to this, which now means that I can use it. So here is the function signature. So we have a callback and then we have a user parameters thing. And then if we look at this, then this is what the callback basically requires us to have. So it's a void function, which has the following parameters. So let's grab that. Up here, I'm just going to make a static void, and then we'll call this GL debug message callback. We'll implement this function. This is the message. So we're trying to be brief here. So let's just print the message, I guess. Okay, I think I may also need to bump this up to 4.3, and then we can have it be compatibility. I'm not sure if this is required, but OpenGL debug context might need to be enabled. Once we have the OpenGL context, we need to also enable debug output. And yeah, these two I remember as being required actually, but this one I don't quite. I think the important thing now is just to check to make sure that we have indeed done everything that needs to be done in order for it to actually work, like the debug message callback. So if I just try and do something like draw arrays, and then I'll just type in a random number for the mode, which should be wrong, and then let's just like try and run this. This should basically be a test of whether or not that debug message callback is working. And you can see it is in fact working. And if we have a look here, there's our log message. It's saying that there's an invalid primitive mode because we're supposed to type in something like GL triangles, which has a value that is not, 582,000. So the callback is working. However, we are crashing. So now this has in fact become Cherno helps fix an 11-year-old's game engine. So let's take a look at this situation, right? And what's actually going on. So it's crashing in a very specific place. I mean, I don't actually know where it's crashing. It looks like it might be swap buffers, but it could also be the line before swap buffers. The reason why is because the debugger is a little bit weird sometimes when it comes to this. So I would put a breakpoint here, hit F10, and then you can see that crash has already happened and we haven't run this yet. It is possible to get crashes in either, because a lot of the times what actually happens is GLFW swap buffers is the thing that actually tells the GPU to like run, right? And it will wait until it's finished running. So if something happens kind of in the GPU driver side when it's supposed to be rendering, then you can get a crash within kind of here. But you can see it's happened basically immediately here, which, is interesting because it's seemingly like we haven't submitted anything that could be null here, but a lot of things could actually be null. And we know something is null because it's saying there's an access violation reading location 0, right? So 0 is null. So we're trying to basically read from a memory address of 0, which is not a thing. So something that would be read from by a draw command here, by a draw call, is just null. So what could it possibly be? Well, it's going to either be this vertex array object, which would contain a vertex buffer and an element buffer. Yes, I said element buffer, not index buffer, because I'm using OpenGL. Figured I would, no, I'm never going to say element buffer again. Vertex array object contains a vertex buffer and an index buffer, and then we have a shaded program. Those are basically the 3 bits here. So either the shade is null, the actual vertex array object that contains like the vertex attribute layout as well as the buffers. One of the buffers could be null, or it could be null, and that's basically it. So now it's just like, okay, what's going on? Well, the shaded program I can see has an ID of 0, which that's already not promising. So, and we did have to like specify which shaders we wanted to load, and it was being a bit weird with the shaders. So that's definitely something that we might need to fix. Okay, so I've just verified that the shaders are actually there. So if we keep debugging shader program, you can see that the ID is in fact 0, which that's not a valid, I don't remember if that's a valid ID or not. Don't think it is. Wait a minute. What? Where's all the code that's supposed to compile the shaders? Are you for real? It's been commented out. He's 11. He's 11. It's fine. I also like that he's decided to specifically have a separate public static function. That's not static, but having a public function here called compile shaders that does that instead of just, calling GL compile shader like that. So that's, yeah, a little bit weird. We'll keep that though. I don't think that's, it's not going to make it not work, but I just don't know why it's commented out. Everything looks pretty good, like in the code. I mean, I don't remember this off the top of my head exactly, but even deleting, cleaning up at the end, create program, test shader, link program, looks great. Why was it commented out? I don't know. Why were the paths hard-coded either? I don't know. Is this just going to work now? Okay, so this didn't actually work. We've loaded the source code, but GL create shader, it does not work. Okay, yes, I know why. Because we haven't actually initialized an OpenGL context yet. So one thing that I noticed that was not correct as well is that these shaders, you can see they're basically just sitting in like global kind of space here, right? They're not a member of this or anything like that. With shaders, in fact, with any resources, right? Shaders are resources as well, like textures, whatever else you might have. You need to make sure that they are not ever in this kind of global space or like static initialization space, because then they just won't work because they rely on something else, right? They're dependent on this stuff happening first, and glfw make context current. After that, we have, and in fact, in this case, you'd also have to go through this and actually load the functions that you're trying to use. And then from line like 51 onwards, that's when we can now actually run those functions, those OpenGL functions. If it doesn't use OpenGL functions, then it's probably okay, as long as it's not dependent on other things. But if it uses OpenGL functions, you need to kind of load those functions first, right? So that's why typically what I would do is at some point here, you know, you've initialized glad, that actually happens over here. And then you're initializing I'm GUI, sure. Like basically at any time after this, you could be like, okay, I'm going to load my resources here, including my shaders. So how would I load these specific shaders? Well, you've got two options here. Either you make it like a pointer, so you could make it a unique pointer over here. So you could have like private, kind of wrap it in like a unique pointer or whatever and just do it that way. Or alternatively, I might be tempted to do this. I don't know why this class is called shaders and not shader, by the way, considering it represents a single shader, but whatever. What you could do is make a default constructor that doesn't do anything, because your actual constructor is what compiles the shader. That's the thing that we can't run. So you can just make a default constructor that just creates like an empty object with like a, in this case, it would be a random ID. Probably set this to 0 by default, and it would create a log. Not ideal, I think, because creating like a log for it, whatever. The point is you could do something like this, and then we could take this like shader program, we could move it over here, but just not set it to anything, right? I'd probably call it m underscore shader program, but it, whatever, doesn't matter. I mean, unless you want to get into potentially good habits, but that's subjective anyway. And then this whole shader program, we're going to cut from there and we're going to move it to after that context has been loaded, right? So we can put it right over here. And of course, we'll just set it equal to a new instance of that class, basically. And we're just creating these like on the stack and stuff, so it's okay. There's no like heap memory allocation. And for that reason, it's probably better to do it this way rather than involve like unique pointers and like, you know, dynamic allocation and all that stuff unless you need it, which we don't in this case. Okay, so once we've got that shader program here, we should be able to use everything as normal. So let's go ahead and try and run this again. We'll fix the errors first, I guess. So yeah, so now that we move shaders here, we actually have to include that. It's weird because it wasn't really included here. Like as in we were using it here, weren't we? And it wasn't included. Well, that's weird. But anyway, let me just try and include shaders.h, which is in renderer shaders. Hopefully that doesn't include core application. Doesn't look like it does though, so that's good. Let's try build this. And F5. Okay, we're still crashing here. Program shader state performance warning. That's probably okay. Shader's destroyed. Log destroyed. Oh, well, that's fine, I think. Okay, so we're still access violation with... Okay, we've got an ID now. So do we also have to fix the VAO? Okay, that ID is wrong. That ID is just flat out wrong. Wait, actually... We're making a new VAO here. How did I not notice that before? Oh boy. Oh look, and here's link VBO to VAO using a certain layout. I'm in too deep to stop now, right? I'm in too deep. So let's not think about it and let's keep going. This is good. Again, it's commented out, but this is good. We obviously can't make it here. We should make it like, whatever. I just realized there's no point making any of this member variables because it's all happening within this stack frame anyway. So maybe after we have the shader, I'm just gonna make a VAO here. What are the vertex buffers? Maybe we should look at the shaders. Like I wanna actually maybe look at the shaders to see what they're trying to do. So this is, okay, just a vertex attribute. Okay, so we're just trying to draw like a red triangle, it looks like. I mean, I don't know if it's a triangle or not, but okay. So that's super easy. So we just need one attribute that's this. And I think that's what this was doing, right? Yep, 3 floats. I just don't know why this is all commented out. So this actually looks good. I think it's all okay here. Where does the vertex buffer get created though? I don't think there is a vertex buffer. Oh, look, 9. So we were trying to draw 9 indices. Okay, this is crazy. Oh, look, VBO. So we've got a VBO. Look, gen buffers, buffer data, vertices. Look, this has been commented out. Can't believe I got sucked into reviewing this. Oh, look, EBO, that's our element buffer object. So it gets kind of, okay, I don't think he understands exactly how this is just making a new object and then deleting it. It's not referencing some existing global one or whatever. Kind of like shader program is though. So, I mean, you know, this is beginning to feel more authentic, right? This is beginning to feel more like something that an 11-year-old would be capable of, right? Because I feel like I mean, I was 16, not 11, so you'd expect me to be maybe a little bit more aware of what's going on, but I also remember not really quite understanding how all of this works, like to this extent. Okay, let's get a triangle rendering for Anthony, for 11-year-old Anthony. I have a soft spot. I've got kids myself now, so I've just got a soft spot, I guess. That's why I'm doing this. Okay, so we don't need to do this. We don't need to make any of these. Let's actually copy this, and then we'll get rid of this, so we're still kind of deleting everything. And then up here, since he's already got like everything, he just needs to actually set the data for some reason that's not here. I don't know why it's 9 indices either. I'm not sure exactly what's going on. We're just going to render a single triangle. Maybe actually let's render a square, because that way it can actually show the vertex buffers, sorry, the index buffer, the element buffer being used. So when we make the VBO using his API, I like how everything's like VBO, VBO, VBO. Like, I don't think this is going to compile with GCC. Okay, so we've got a constructor here that takes in vertices and a size, right? And that presumably works. So let's go ahead and just make, we'll use an std array here. We'll do float, and we'll go 4 times 3 maybe. Negative 0.5, negative 0.5. I guess I'll go, is clockwise or anti-clockwise the normal winding for OpenGL? I'm going to try and go counterclockwise here. Okay, so basically got this corner over here, then we're going this way, so we're going anti-clockwise, counterclockwise, then we're going up here for this one, and then this green one over here is here. So we're going this way, and we're making one of these out of like 2 triangles, as is going to happen based on our index buffer that we haven't created yet. Okay, and let's do the same thing for the indices. This is going to be a bit easier though. So we'll do 32-bit indices, not that we need them for this example. 0, 1, 2, 2, 3, 0. So 0, 1, 2 draws us this, and then 2, 3, 0 draws us that. I'm trying to be quick here. I actually expand more on this, but in Vulkan, in my cubed series, which is like every episode's like 2.5 hours long. So I'll have it linked up there in case you want more details on like rendering and stuff, because that's actually a pretty cool series that's going on that has a lot of like depth to it. But we're using Vulkan there, so things are a bit more complicated. Okay, so now that we've done that, we can create vertices.data and vertices.size. Now it's very important to make sure that size is correct in the sense that like, I'm guessing, yeah, this is just a buffer. So size is going to be in bytes. So that means we have to do size times size of float. And then for the element buffer object, for the index buffer, we've got our indices.size, indices.data, and indices.size. And then again, I'm just going to have a look. So buffer data and then size. So this is going to be in bytes. And by the way, if you don't just happen to know that and you want to check, you can obviously always look it up, like in the documentation. And then we can see that the size parameter refers to the size in bytes, right? So it's not the count of how many indices, it's the actual size in bytes, which just means that we need to do a time size of uint32t. Okay, so we got that. Now we need to bind the vertex buffer to the vertex array, which is the thing that's also going to create the, let's maybe bring this down here. That's the thing that's also going to create like that attribute for us. So if we do link VBO, which already exists obviously in that function, then layout, what's layout? Oh, that's just going to be 0. That's going to be number 1. So layout, I guess he's called it layout because it's layout here, location equals 0. So that's what goes in here. All right, so we've got VAO, we've got a VBO. That's linked now technically. So that should mean, and we bind it. So that should mean that we can now just bind our VAO and draw, and it should be okay. So let's fix maybe some errors here. Okay, so I think according to his code, you actually have to bind this first, maybe. Oh, we did it, kind of. Look at this, it's even got I'm GUI here. There's our beautiful rectangle. Poof, all right. Look, even resizing works. So this, I don't think this is really an important message, because at the moment we're actually printing everything, including like trace messages and stuff. So if you wanted to limit it to a particular like severity, then you can also do that, and then you probably wouldn't get the log message. But we did manage to get this working. You know, I didn't really do much of a code review. I don't even know if I'm gonna call this an episode of the code review series, but let me know what you guys thought of this kind of video where someone just sends me code and I fix it. And like, is this good content? Did you enjoy this? I'm sure it was helpful for this particular person, but let me know if you want to see more of this kind of thing. The actual code, it's hard to like judge too much of the code, because obviously a lot of it is just pulled from like example applications, like all of this I'm GUI initialization and this like GLFW stuff. Everything's happening basically within this single run function, apart from some objects that are being created and used like as separate instances of objects like we saw there. This was obviously wrong, how we were just like creating and then deleting, creating, deleting, not knowing potentially how to reference existing instances of objects that were stored somewhere else. There's a lot of like emptiness everywhere, and like kind of how we saw like with layers not really being a thing. So it's still very new. But again, you know, for an 11-year-old, assuming that is in fact true, you know, it's obviously good to get familiar with using like the actual language itself, which seems to be happening to an extent. Precompiled headers are probably something that I wouldn't even recommend to be used yet, because that's just gonna overcomplicate things for zero benefit at all. Oh, sorry, the color here was this like some kind of HDR color? That's funny. So these colors are generally between 0 and 1, right? So if you wanted like red, you do like 1, 0, 0, and then 1, I guess, for the alpha, unless you have like an HDR buffer, which I don't think you do. But anyway, hopefully this helps. I don't know if I should like submit all this as a pull request or something. Let me know what you guys think in the comment section below. Obviously, this might not be exactly the correct code going forward, but then again, this is just like a repository where someone's playing around with C++ and OpenGL, right? So it's not exactly like you didn't do this properly in the sense of like, he didn't want to draw a square, he wanted to draw something with 9 indices. At the very least, maybe it's like some kind of example. If you guys want me to take a look at your code or your project or potentially fix it as well, then send it into chernoreview@gmail.com. That email address and some instructions will be in the description below. Also, don't forget, you can check out CodeRabbit by using my link in the description below, and I will see you next time. Goodbye.